Okay, so, ladies and gentlemen, we're going to talk about single replacement reactions today. Our learning target is to classify the types of chemical reactions. Our success criteria to hit this learning target is to, number one, be able to balance a chemical equation. We've been doing this through the entire unit. Number two, to describe and identify a single replacement reaction. To predict a single replacement reaction. And finally, to use the activity series to predict whether a single replacement reaction occurs. So make sure that you have that activity series out and handy, because we're going to be using it a lot with this single replacement reaction. Now, the single replacement format is as follows. Element A will react with compound BC to yield element B and compound AC. So basically what happened is that A there on the format replaced the B and kicked the B out of the compound. We must use the activity series to see if element A has enough activity to remove element B. All right? So element A has to be higher on the activity series than what element B was. Now here are the 5 different types of single replacement reactions. A metal reacting with an aqueous salt yields a new metal and a new salt. An active metal reacts with water to give a metal hydroxide and hydrogen. Well, how do we determine whether it's an active metal? Well, we're going to be looking at our activity series. A metal plus an acid will yield a salt, which is dissolved, and bubble out hydrogen gas. Number 4 is a special one we're going to see because it's dealing with a halogen. So the replacement is a little bit different. A halogen plus an aqueous salt gives us a new salt and a new halogen. And finally, a metal oxide reacting with hydrogen will give us the metal and water vapor. So, go ahead and write this one down. This is our very first one. Sodium oxide plus calcium. So what I'm going to do, just like I started before, I am going to write sodium oxide out, and I'm going to write calcium out. My yields arrow there. Now I am going to come up to my this is going to get old if I have to do this every time. I'm going to come down here. Here's my activity series. All right. Well, actually, let's not do that quite yet, because, oh boy, let's not do that quite yet because we have to decide which one of these reactions it is. So I have a metal oxide and a metal. So metal and an aqueous salt. Well, that could be that. Do I have any of these that have a metal oxide? Well, here's a metal oxide. Here's a metal oxide and hydrogen. Is that the case here? Do I have a metal oxide and hydrogen? I don't. I have a metal oxide and a metal and calcium. So basically, as I look at this, it could be one. I don't have water. I don't have an acid. I don't have a halogen. I don't have hydrogen. So this has got to be a single replacement number 1. So I'm going to put up here SR number 1. Now looking at my packet, it says must use activity series. All right, so I have to come up with my activity series here. And it's not working. Once again, my taskbar, here's my activity series. So I have to look on my activity series and say, okay, is calcium high enough to replace sodium? Well, I'm looking at those two. Those two are both right here. Is calcium higher than sodium? It's only one higher, but it is higher, right? So calcium is going to replace the sodium. So I look at this here, and it says that I'm going to get a new metal and a new salt. Well, my new salt is going to be calcium oxide. Remember that calcium is a 2+, oxygen's a 2-, so my charges equal out there. And my new metal being formed is going to be sodium. So now all I have to do is look at this and say, is that a balanced chemical equation? It's not balanced yet, is it? What do I need to do? I need to have a 2 before the sodium right there. And now I do have a balanced chemical equation. Any questions? Okay. Moving on. My next one is iron plus copper 1 chloride. Iron plus copper 1 chloride. Fe plus, copper tells me copper is a 1+. I know chlorine's a 1-. CuCl2. Actually, it's not a 2. That would be copper 2. CuCl. So once again, I'm going to go through and I'm going to look. Do I have a metal and an aqueous salt? Yes, I do. Do I have an active metal and water? No. So it's not 2. Okay? I don't have an acid. I don't have a halogen. I don't have a metal oxide and hydrogen. So once again, this one is going to be a single replacement, number 1. So again, I have to determine if, dang it, on my activity series, if we're good enough, if we're more active. So let me switch my screen again. Back to my activity series. Now I'm on my activity series here. And I'm looking to see, can iron replace copper? Well, all the way down here is copper. Where is iron? Iron's right here. So can iron replace the copper? Absolutely. So iron will replace copper. So here's the point, ladies and gentlemen. Do I know which iron it's going to make? Iron 2 or iron 3? I don't. So I could use either one and be correct. That would be how something we would have to do testing with to determine whether we had iron 2 or iron 3. And if you remember that, we actually did test in the lab, iron 2 or iron 3. All right? So we've done that test. So let's just say for giggles, I picked that I want iron 3. So I'm going to put FeCl3, and I'm going to release copper. Now this leaves some balancing to do, folks, because I can see that my chlorines are not balanced. So I have to put a 3 in front of my copper 1 chloride. That gets my chlorines balanced, but then that unbalances my copper. So over here I have to put a 3. And once I have done that, do we have a balanced chemical equation? Yes. So we are now balanced. Chromium and steam. So chromium is my metal. What's steam, ladies and gentlemen? What is steam? Water in the gas state. Okay. So I have water in the gas state. And I could put gas like this to signify that I have steam. Now, it is important to know that. Okay. So I have a metal and water. So I look, do I have a metal and water? Oh, right there. Right there. So, even though it's steam, it's still water, right? So this is going to be a single replacement number 2. Now, on my single replacement number 2, once again, I need to go back. I need to go back to my activity series. And if I make this a little bit bigger, so you folks can see it a little better, reacts with steam, liberating hydrogen gas. Right here. Can you see that line on your activity series? Right here. React with steam, liberating hydrogen gas. Now, is chromium above that line? It is, correct? So, chromium, since chromium's all the way up here, chromium is above that line we're talking about. So, chromium will react with steam. So, as I'm looking back here, okay, my active metal plus water will give me a metal hydroxide and hydrogen. Metal hydroxide and hydrogen. So, I come back here and say, okay, it's going to give me a metal hydroxide and hydrogen. Remember, hydrogen's a super 7, so that's going to be diatomic. Well, I know what my metal is. I know what my metal is. My metal is chromium. So it's going to give me chromium hydroxide and hydrogen. Now, looking at my periodic table, chromium takes a 3, chromium takes a 6, chromium takes a 2. So 2, 3, and 6. And once again, I can pick either one. So for this one, I'm going to pick chromium 2 hydroxide. So my formula, chromium 2, hydroxide's a -1, so I'm going to need 2 of those. Once again, my hydrogen gas is diatomic, so I'm going to need to do some balancing. And since I picked chromium 2, this is going to balance pretty easily because all I need to do is put a 2 right here. Now I have 4 hydrogens and I have 2 oxygens, and that balances out my chemical equation. Now, if you would have put chromium 3 hydroxide, would you have been wrong? No, you could have used chromium 3. Okay. Zinc, and hydrobromic acid. So once again, I got to go back to my acid rules. IC 1 or 3. I see that hydro in there, so I know that this is acid rule number 1. So I'm looking for bromide. So hydrobromic acid is HBr. Now, somewhere in my mind, I can remember that there was one of these single replacements that was dealing with an acid. And here it is, a metal and an acid. Is that what we're dealing with right now? Absolutely. So this is a single replacement, number 3. And what we have is we're getting a new salt and hydrogen gas. Okay? A new salt and hydrogen gas. So, as I look back here, I once again have to go to my activity series. So I find my activity series here on my taskbar, and it says right here is the line above the H. Right here's the line above the H. Reacts with acids liberating hydrogen gas. Well, that's the line right there I need for a single replacement number 3. So I have to determine, what was my metal? Zinc? Okay. Is zinc above that line? Absolutely. Zinc's all the way up here. So zinc will make this reaction occur. So I'm going to once again going to be forming a new salt and hydrogen gas. So what's my new salt going to be? Well, just pretend that that zinc right here, once again, is replacing that hydrogen. So that's going to give me zinc bromide. Zinc's a 2+, bromide is a 1-, so it's going to be ZnBr2, and we're going to release hydrogen gas. When we release the hydrogen gas, make sure you have that being a super 7, because hydrogen, again, is diatomic. So when I have done this, single replacement number 3, and I'm going to get this little arrow out from under there. I don't know why I switched colors either, but I can see that I need to do some balancing. And if I put a 2 in front of there, I have balanced my equation. Any questions? Okay. Here's the one I was talking about, and you have to just recognize. Okay? Bromine, which once again, bromine's a diatomic, it's a super 7, plus sodium iodide. Now, like I said, this is the one you just have to recognize, because bromine here, bromine is a halogen. So, is bromine going to try to replace sodium? No. Bromine is going to try to replace the iodine. Bromine's going to try to replace the iodine. So this is number 4 right here. So if it occurs, I'm going to get a new salt and a new halogen. So if bromine is active enough, it will replace the iodine. Now on my activity series, I have a little box up at the top left of it, right here. And it says halogen activity series. And if you look at your periodic table, if you look at the halogens on the periodic table, the top one's fluorine, then chlorine, then bromine, then iodine. So it follows the activity or the order from top down on your periodic table. Now, is bromine right here active enough to replace iodine? It is. Bromine is active enough to replace iodine, So what we're going to have happen is we're going to get now sodium bromide, and our new halogen's going to be iodine. Once again, remember, iodine's a super 7. Iodine's a super 7. So now the final thing I need to do is I need to do some balancing. And I'm going to start by balancing up my iodines. Then I'm going to balance up my bromines. And when I do so, I balanced up my entire equation. So that's one. We just have to recognize that we have a halogen, and it's going to replace the back end, not the front end. Water and sodium. Water and sodium. So I have H2O plus sodium, Na. Now, once again, ladies and gentlemen, I look at my different ones, metal and an aqueous salt. Here's one with water and an active metal. Well, I have water and I have sodium. That's an alkali metal, so we're going to have to see if it's active enough. So this is going to be a single replacement number 2, metal hydroxide and hydrogen. So single replacement number 2, which is a metal hydroxide and hydrogen. Now I better go, I have water now. And once again, remember that water, I can't assume that this is steam because it just says water. So I'm going to look at my activity series and say, okay, right here, reacts with cold water, liberating hydrogen gas. So here's a line on my activity series. It's higher up than the one with the steam down here. Let me get that out of the way. So I have to look to see, okay, I was dealing with sodium, right? So sodium's above that line, correct? So this reaction will indeed occur. So I look and I say, okay, I will have this occur. So I'm going to have a metal hydroxide, and that metal is sodium. Sodium's a 1 plus, hydroxide's a 1 minus. So NaOH, my hydrogen gas here. So I look at this and I say, okay, I have an equation that is not balanced, correct? Because I have too many, or I don't have enough hydrogens on one side. So if I look at this and I put a 2 here, now that gives me 2 hydrogens, 4 hydrogens on my product side. So I need to have 4 hydrogens on my reactant side. My reactant side has 2 oxygens, 2 oxygens. So I believe all I have to do is put a 2 there, and I have a balanced equation. Would you agree with me? Okay. Any questions about that particular one? Now, our final one today, I want you to do. So here is our final one today. I want you to work this one, and then I will work it. I have copper reacting with iron to nitrate. So as I look on my single replacement, a metal and an aqueous salt, yeah, I could have that. I don't have water. I don't have an acid. I don't have a halogen. I don't have a metal oxide and hydrogen. So this has to be a single replacement number 1. So I put single replacement number 1. Now I need to go back and check my activity series. I look at my activity series and we've done this before, okay, except for we had it the other way. Is copper all the way down here, is copper active enough to replace iron? It is not active enough. So copper does not have enough juice to replace iron in this particular reaction. So what I'm going to put simply is NR, because no reaction will occur. Copper does not have enough to replace the iron. Any questions for me?